All right, so this do now is not in your packet, but you can go ahead and solve it on the back side of your packet or on a separate sheet of paper. So what we're reviewing here is a 45, 45, 90 triangle. Okay, and the first thing I'm going to do is look at the legs that make up my right angle, and I know they both, we can call them A, and the hypotenuse we can call A times the square root of 2. So I got to look at the information I know, and I know the hypotenuse. So if I just take away the square root of 2, I'm left with A. So that means I know that both sides, or both legs, are going to be 3. So A equals 3, B equals 3. All right, here we've got a 30, 60, 90 right triangle. So I'm going to label this. This over here is my short leg, which I know is equal to A. This is my hypotenuse, which is equal to 2 times A. And this is my long leg, which is A times the square root of 3. That's the shortcut. So if I know my hypotenuse is 4, that means that 2A equals 4. So I'm just going to split it in half to get 2. So now I know that side Y equals 2, because this is the short leg, okay? And now I know the long leg, or in this case x, is going to equal 2 times the square root of 3. And those were the shortcuts we learned yesterday, about the 45, 45, 90, and the 30, 60, 90. Okay, so today we're going to add in some triangles, and we're going to learn some cool ratios that you can set up for similar right triangles. Please remember that there are 3 similar triangle theorems: side, 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 angle, and angle, angle. Okay? And again, if you know that 2 angles are congruent, then you know 2 triangles are similar. If you know all their sides are proportional, you can set up ratios, then you know they're similar. So let's go ahead and look. We're going to split it up into 3 triangles. So first we're going to bring down an altitude. In altitude, you should be thinking height. So we're going to look at the height of this triangle here. And what you should notice is that if you bring down an altitude, you're going to actually form 3 right triangles. A big one, the one on the left, and the one on the right. So I'm going to draw them all this way, just so you can see the relationship. So if I'm looking at the big triangle, B is my right angle, A is over here, and C is up here. You can see my things are a little off. There we go. All right, then I'm going to look at this triangle on the left, which is right here. But I'm going to flip it, and I'm going to call this point D. Okay? So now I'm looking at the smaller triangle, which is in red. This is D, this is A, and this is B up here. And then the third triangle that you can see is right here, and I'll draw this one in green. And again, I'm going to turn it and flip it. So this one here, C is at the top. This is my right angle, D, and over here is B. All right, and I'm going to not really worry about comparing the side lengths. But what I do know is that angle C, so this angle here is going to be congruent to this angle, which is congruent to this angle. And I know this angle here is congruent to this angle here, which is congruent to this angle here. So they're all similar right triangles when you drop in altitude. And that means their side lengths would be proportional. So this side is proportional, CA is proportional to BA, which is proportional to CB, and so on and so forth. All right, so there is a skill that you're going to need to know how to do to be successful today. And this skill is called the geometric mean. Now, if you just have, like let's say x over 4 equals 4 over 7, okay? This is a fairly simple, let's make this an 8. This is a fairly simple equation to solve. You just take x times 8, which is 8x, and 4 times 4, which is 16, which gives you x equal to 2, okay? Now, today we're going to look at some ratios, some proportions that are set up this way, but we're also going to look at some proportions that are set up this way. And what this is called is a geometric mean. It's a special type of average where we multiply numbers together and then take the square root. So for example, this would be a times b on this side, and over here we would have x squared, because x times x is x squared. Well, the last step is going to be to have to take the square root of both sides so we can figure out what just x is. So let's give you an example. Let's say we're finding the geometric mean of 3 and 4. So we'll call 3a and call 4b. So I'm going to set up my ratio as 3 over x equals x over 4. And then when I cross multiply, I get x squared equaling 12. Well, you could type that in the calculator. If I want to know what x is, I have to take the square root of x squared, which means I have to do the same thing on the other side to keep it balanced. So yesterday we learned that you could simplify the radical. I'm just listing factor pairs until I find a perfect square. And I know 4 is a perfect square because 4 is 2 times 2. Okay? So I'm going to rewrite this as 4 times 3. The square root of 4 is 2, and I'm left with the square root of 3. So my final answer would be x equals 2 times the square root of 3. Or, of course, you can write it in decimal form, which would be like 3.5. So that's the skill we're going to need to be successful today. All right, so today when we have a situation where we have an altitude drawn in a right triangle, remember then we have 3 similar right triangles, right? The one in the big one, the one on the left, and the one on the right. And you can set up this ratio called side over altitude equals altitude over side. So in simple forms, we'll write it as SA equals A over S. So the first thing you want to do is label your stuff. So the altitude is the height, so this would be your A. And the sides make up the hypotenuse of the large triangle. So this would be side 1, this would be side 2. And now you just set up your ratio and solve. So it's going to be side 1 over side 2. So 2 over 7. And the 7 is going to repeat, 7 over x. And then I'm going to cross multiply and get 2x equals 49. So x equals, hopefully you're beating me right now, 24.5. So now I know that this side is 24.5. Right? This is called the side altitude side, SAAS. So I'm going to label this S1, this is A, and this is S2. So it's going to be 3 over h equals h over 9. H times h is h squared. 9 times 3 is 27. Well, this is one where I have to take the square root of both sides. So 27 times 1, no, not times, 3 goes into 27 9 times. And there's my perfect square. So I'm going to rewrite this as 9 and 3. And the square root of 9 can come out as 3. The square root of 3 is left behind. And this is h. The other thing you could have done is just simply taken in second. X squared 27 is about 5.2. Okay. Now this one has an extra step. Remember, you need 2 sides. So I know this side is, I'll just call it side 1, but I don't know what side 2 is, but I can find it real easily by simply taking 25 minus 9, which is 16. So this side is 16. Remember the 2 parts, part plus part equals the whole. So now I know this is my A, this is my side 2. So I'm going to do 9 over x equals x over 16. Now I need to know what 9 times 16 is. It's 144. So this would be x squared equals 144. And the beauty of this one is that 144 is a perfect square. So I can just simply say that x equals 12. Okay, remember that. Remember, this is when an altitude is either given or marked. Okay, so in this case, the altitude was marked with a variable, and that's what I'm looking for. Or, if you're given the altitude, you may use SAAS. You must have an altitude to use this. Okay. The second one is, you'll notice when you're looking at our other ratio, the altitude is there to make the three triangles, but you don't have any information about it. Okay? And so we call this the hypotenuse leg theorem, where it's HLLS. All right? So the first thing you want to look at is the big triangle. And you're going to label, if you look at the big triangle, this is the hypotenuse. If you look at the big triangle, this is the hypotenuse. Okay? So that's the first thing you want to put down. Then you're going to look at that big triangle again. This is a leg of the big triangle. Again, we're looking at the big triangle. This is a leg. And the last part is the side. So this right here is one of the sides of the hypotenuse. So we're labeling it S, the side of the hypotenuse. And then how you set up this equation, or this proportion, is H over L equals L over S. So the first to come is the hypotenuse, which is 13, over the leg, which is 5. You're going to repeat the leg, put it over the side. Remember, the sides are the piece of the hypotenuse in both cases. So this would be 13x equals 25. I don't have to do any special simplifying this one, so I'm just going to take 25 divided by 13, and I get x equal to about 1.9. Decimals are okay. You could say 1.92 if it says to round to the hundredths place. Okay. So over here again, I'm going to start with h, which is x, over 36. And that's going to equal 36 again over 33. So this would be 33x equals 1,296. Divide that by 13, and you get x equal to 99.7. So the hardest part is knowing when to use what. And if you're given radicals, I would just convert this. I would just multiply 7 times the square root of 33, which is 40.21. So I'm going to rewrite that as 40.21. That's the way I would solve this, if they're given in radical. All right, so let's try a couple of these. I know this one I'm going to use SAAS because I'm given an altitude. So I'm going to know that this is S, this is A, this is S. So I'm going to crisscross this 9 because it's not necessary. And over here, because I'm not looking at the altitude, I know this is going to be HLLS. So I'm going to look at the big triangle first. This is my hypotenuse. So I actually have to add those together. You will have to add these together, which is 92. And so this is my H. All right, now I got to look. My L has to be this because that's what I'm looking for. And then I need my S. So I could either use 22 or 70 as my S. Well, I have to use this one here because if I'm using this triangle as my leg, I have to use this as my S. So if I'm going to set this one up, it would be 5 over x equals x over 13. And over here, it would be h, 92, over x equals x over, and again, I have to use 70 because it's on the same triangle. And then I would cross multiply and divide. Okay, these are a little bit more challenging because, again, this one I'm going to have to use HLLS. This is my hypotenuse, so it would be x plus 9. That's my hypotenuse. This is my leg, so this is my side. They have to be on the same triangle. So this would be x plus 9 over 15 equals 15 over 9. And then you would cross multiply. Don't forget to multiply the whole thing. Okay, to practice these, you're going to go to Quizlet, and the link is attached. So go ahead and go into Quizlet, practice. You can use any one of the practice methods you want. Use a separate sheet of paper to show your work.